biotechnology and its application. In this topic, we will discuss how biotechnology will help us in different type of molecular diagnosis. In turn, it will help us in solving different health issues. You know, for effective treatment of a disease, two things is very much important. So if you want to treat one disease effectively, for effective treatment of a disease, two things is very important. One, if you know as soon as possible what is the disease actually and what is the causative agent, then it will be very easy for you or for a doctor to take necessary steps for curing you from the disease. So early diagnosis is very much important. Early diagnosis. As early as will be the diagnosis of a disease, chance of getting effective treatment will be more higher. And number two is understanding the pathophysiology of this particular pathogen or disease. That is also very important. So understanding pathophysiology. Pathophysiology means actually that when some pathogen, it may be a virus, it may be bacteria, will enter into your body, it will surely affect the normal physiological functions of your body. That's why we would call it a disease. So we must know it very well. We should have the knowledge that which physiological process of our body is likely to be affected by that particular pathogen which has affected us. This is not the matter of the patient. This is matter of the doctor actually, and it's not a problem actually, because if the disease is a known disease and the pathogen is a known pathogen, then already one doctor knows about the pathophysiology of it. So it's not a big deal. The big deal is, or the big problem is early diagnosis. As early as you can diagnose one pathogen inside your body, it will be more helpful for a doctor to give you proper treatment. But what is the problem? The problem with our conventional medical sciences and in our conventional ways in which we try to diagnose one disease, in those ways, normally what we try actually, we test for urine, serum means blood. Normally, to detect one pathogen, we use these fluids of our body or many other fluids. It may be sometimes saliva to detect one disease. But using this conventional procedure, analyzing urine, analyzing serum or blood, or it may be sometimes saliva, if we analyze this, we get a diagnosis. But early diagnosis is not possible in this way. Because the presence of a pathogen in your body is suspected when the disease or the pathogen has already produced a lot of disease symptoms in your body. When someone is just freely moving, there is no symptom of disease, no one will suspect that there is a disease. If there are a lot of symptoms, for example, if you are coughing or if you are sneezing or there is a lot of fever in your body, then you will suspect that something wrong has happened in your body and you will go for test. But by this time, when the disease symptoms has already been appeared in your body, by this time the pathogen's concentration is already very high in your body. The pathogen has entered your body, and you know there is a term called incubation period. So disease symptoms will appear only after that incubation period. But during that incubation period, no one suspects. And using this conventional method, detecting the pathogen is not possible, because then the concentration of that particular pathogen is very low in our body. So it is a critical issue, and biotechnology will help us to solve this problem, early diagnosis of any disease. How biotechnology will help us in this process, let us see. Biotechnology has developed a lot of technologies which will help us, or which will facilitate in early diagnosis of one disease. Among them, two is very familiar. Number one is ELISA, and number two is PCR. You all know about PCR. So if there is a very low concentration of disease, very low concentration of pathogen in your body, it can be detected by PCR. How? I think you all know, by simply amplifying the nucleic acid in the blood. So if there is a little bit amount of nucleic acid in your body, this will be amplified by PCR. So PCR, you all know the full form of PCR, I think, polymerase chain reaction. Polymerase chain reaction. And another one, modern technique, that is ELISA. ELISA, the full form of ELISA is enzyme linked immunosorbent assay. It will also help us in detecting early the pathogens of a disease. So early detection is very much important. For example, you will think that when you understand that there one earthquake has been happened, when everything around you start to shiver, everything around you start to shiver, then you come to know that earthquake has been occurring, or earthquake is going on. But and then you are not prepared for the earthquake. The most important point is you are not prepared for the earthquake. But nowadays a lot of technologies and a lot of devices has been discovered which will inform us sometimes before the earthquake will come. So you imagine if you can come to know 1 hour before or 2 hours before when the earthquake will come, so you will get a lot of opportunities, a lot of steps you will take to come over, to cope up with the situation which will come from that earthquake. So like the earthquake or like any natural calamity, if you know earlier it that it is going to happen, it will help you to cope up with that situation which will come after that natural calamities. Like that, early diagnosis of any disease will surely help us in improving our healthcare facilities, and in the case biotechnology will help us, and it has given us two important technology. One is ELISA, one is PCR. Let us go into that.